This is Josh White with JW Math Tutoring. In today's video, I'm going to go through the 6 hardest problems from the April 2023 ACT math exam, Form Z18. So let's go ahead and take a look.
But life is a dream that calculus could never predict.
Just before I begin this video, going through these 6 hardest ACT problems from this test, I just want to mention a couple things. First, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, the reason I'm only highlighting 6 problems from this test is because I've gotten hit with copyright strikes from the ACT when I published full reviews of completed official tests. So that's the reason why you only see 6 problems instead of the full 60, which I would love to do, full videos on. Lastly, if you're looking for more ACT practice work, please check out my Improve Your ACT Math Score course. You can find it on Udemy. You can find it also on Teachable. There are direct links to both courses in the description of this video below. And basically, this is a comprehensive overview of the math section on the ACT. It covers your common topics in algebra and geometry and probability and statistics, in addition to strategies like back solving, picking numbers, process of elimination, estimation, drawing a picture, essentially in order to help you solve problems as quickly as possible. And it also includes an entire module on using the TI-84 graphing calculator to solve problems as well. Basically, it features over 10 hours of instructional video along those 5 different modules. So please do check that out. Anyways, here are the solutions to these 6 hardest problems. And at this first problem here, number 35, this is part of a set of problems. 33 and 34 as well. They're on the previous page, but I just copied the information that you're given onto this page. So this actually appears on the previous page in the test, but I'm just copying it here so I don't have to keep scrolling back and forth. All right, so in 35, we have the assumption that we're using 5 paper towel sheets per day, and we want to know what's the smallest number of boxes of paper towels we can order to get basically 2 years worth of paper towels. So there's multiple ways you could do this. First thing I would do is I would notice basically it's just going to be kind of like some unit conversions. So we've got 5 sheets per day that are being used, and then just multiply that by 365 days per 1 year. And then, of course, we want 2 years. So we go through, days cancel out, years cancel out. You go ahead, multiply all these values together, and we should get, let's see here, 3,650 total sheets. 3,650. That's the total number of paper towel sheets that we need for 2 years. You mean using at least using exactly 5 paper towel sheets per day. All right. So now, basically what we have to do is figure out how many paper towel sheets are there in a box. So go back to the given information here. 193 sheets in a roll. Okay. The boxes have 6 rolls. So if we just take that, 193 sheets per roll, and there are 6 rolls per box. Rolls cancel out. So we just go ahead and multiply this. We have 1,158 sheets per box. Okay, so now how do we determine the number of sheets that we need? Well, we're basically going to just take these 2 numbers and divide them. I mean, you could go through and you could technically now back solve this. Basically you're just taking 1158 and what do you multiply by in order to make it greater than or equal to 3650? Okay, which is really the same as just taking 3650 and dividing it by 1158. So however you want to think about it, it's going to come out to 3.15. Therefore, the minimum number of boxes you need is 4. If you only ordered 3 boxes, with 1,158 sheets per box. That would give you 3,474 sheets, which is not enough for 5 per day. If you take that and let's see, we divide it by basically number of days in 2 years, which is 365 times 2, we're assuming we do not have a leap year involved. See, that's only 4.75 roughly sheets per day, not 5 sheets per day. So the correct answer to this is letter D, 4. Top of the next page, we're going to look at question number 43, where we have a geometric sequence. Then we're given 2 terms in the sequence, and we want to know what's the value of a third term. So I think the quickest way to do this is to notice that, so in a geometric sequence, you multiply by some number, usually it's r, called the common ratio, and that moves you from term to term to term. So if you have a3, okay, and that's 16 over 3, and then here you have a5, fifth term, which is 64 over 27, like a4 is here in the middle, we don't know what it is. You're multiplying by r to make a4, and then you multiply by r again, times r to make a5. So to get from a3 to a5, you're technically multiplying by the common ratio twice, or by r squared. So in other words, 16 over 3 times r squared is equal to 64 over 27. Now you can just solve this for r. Multiply both sides by 3 over 16 to cancel out all the numbers on the left. If you do this here, 3 and 27 will cancel, and you should be left with 9. 16 and 64 will cancel, and you'll be left with 4. And now you could just square root both sides. So the common ratio here is 2/3. Notice it's less than 1, but that makes sense because 16/3 is larger than 64 over 27. 16 over 3 is 5 point whatever, 5 1/3, whereas 64 over 27 is 2 and something. Okay, so the numbers are getting smaller. Therefore, through this geometric sequence, therefore, we expect the common ratio to be less than 1. All right, so now all we have to do to get from a sub 5 to a8 is multiply by r 3 more times. Because we're starting at a5, you multiply by r once, you're at a6. You multiply by r second time, you're at a7. You multiply by r a third time, you will be at a8. So we're starting at 64 over 27. We multiply basically by 2/3 cubed, r times r times r, or r cubed. Now the problem is the answer choices all have this as 2 to the something and 3 to the something. So what you can do is you can go on your calculator and you could do 64 times 2 to the third and get the value, and 27 times 3 to the third and get the value. Then you'd have to go through the answer choices, and really you don't have to check either the top or the bottom and see which one matches. What 64 basically 64 times 8 is, and what 27 times 9 is. But instead, I'm going to rewrite the 64 here as 2 to the 6th power, and 27 as 3 to the third. So now, when I'm multiplying, I can just go ahead and add the exponents and get 2 to the 9th over 3 to the 6th. So the correct answer for this problem is letter choice C. Notice that I didn't have to find the explicit formula for this. I did not need to find the first term or do any of that stuff, come up with the recursive formula or the explicit formula. I just need to find the common ratio, and then once I have that, I can use the a sub 5 term to find a sub 8. Okay, top of the next page here, question number 50. This is honestly one of the trickiest problems on the test. So basically what's going on here is you kind of have a pattern where this person is saving like $1 more per week, blah, 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 until she gets to $20, and then the whole thing starts over. So like week 1, 2, 3, 4, blah, 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 up to 16. Okay? She does this for an entire year. So essentially what's happening is the first 16 weeks, she's saving 5 plus 6 plus 7 plus 8 plus blah, 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 plus 20. Then, basically for weeks 17 through 32, the same exact thing is happening. And then through weeks 33 through 48, the same exact thing is happening. 5, 6, 7, 8, blah, 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 up to 20. Basically, kind of a repeating pattern here. Then you still have 4 more weeks because we basically have weeks 49, 50, it starts over, 51, and then 52 because there's 52 weeks in a year. And so for those, she's just going to say 5, 6, 7, 8. Okay. So the last 4 weeks, just adding that up, that's not a big deal. 11 plus 7, 18, 18, that's $26. So the question is, how do you determine how much money she saved over the first 48 weeks? And really, all you need to do is figure out how much money she saved over one 16-week time period, and then you could just multiply it by 3 since these are all identical. All right, so here's how you can do it. There is a shortcut formula to figure it out. So I'll go over that in a second. But if you don't know that or don't remember that or haven't learned that, that's fine. Basically, notice what's happening here. Take this smallest amount and the largest amount, okay? 5 plus 20. Notice they happen to add to 25. Then take the next smallest and the next largest, and this would be 19. Notice they happen to be 25. And then if you do 7 and 18, it's also 25. And, hopefully you're starting to see the pattern. 8 and 17 is also 25. And you keep going like that, and then eventually in the middle, you're going to have 12 and 13. And so what you end up with is 8 different pairs, which each add up to $25. So the total amount of money for one 16-week period will be $200. Okay? It's really just 8 again, and if you wanted to, you could just whatever enter all 16 digits in the calculator. It doesn't take you that long, but it's easier if you can recognize the pattern because it will save you time. So, $200 here, $200 here, $200 here. Add those all up. Add the $26 from the last 4 weeks. The total amount she saves is $626. Correct answer for this is letter K. Now, here is the shortcut formula that you may want to memorize, although this does not come up frequently. Like this specific formula comes up once every, like I've seen, at least from the released tests, maybe like once every 4 or 5 years. The shortcut formula is basically as follows, and this is to find basically the amount of money for an increasing, arithmetic sequence. You take the starting amount and you add the end amount. You divide that by 2, in other words, divide that by half, and then you multiply by n. And n here represents the number, basically the number of weeks in this case. In other words, the number of items in the sequence, which would be 16. So in other words, 16 times 5 plus 20, initial amount over final amount, divided by 2. And so notice what happens here. 5 plus 20 is 25. 2 goes into 16 8 times, and this is the exact same thing that I had gotten 8 times 25 just by noticing that essentially there were 8 pairs that each add up to 25. But if you want to memorize the formula, it's right here. Again, first initial amount plus final amount divided by 2, and then multiplied by n, where n is the number of items in your sequence, which in this case would be 16. So correct answer for this is just 626. Next up, we're going to the top of the next page, number 54. So on this problem, what's happening is you have a person, okay, driving 60 miles per hour over a 1-hour round trip, okay? So it's like 30 minutes one way, assume 30 minutes the other way, although I guess technically we don't know. We just really know the total time. So I guess it doesn't have to be split up as like 30 and 30. So let's just look at the whole trip, whatever. 60 miles per hour, and it takes 1 hour. That means the total distance is 60 miles, okay? Because rate times time equals distance. 60 miles per hour times 1 hour means our total distance is just 60 miles, okay? All right, Lately, it's been taking 15 minutes longer each way. That means the trip, which was previously taking 1 hour, is now taking 1.5 hours because you're adding 15 minutes each way, so a quarter of an hour, like there's 0.25 hours, and you're doing it twice. 0.25 hours plus 0.25 hours. So therefore, the total time for the new trip with these delays is 1.5 hours. Again, 15 minutes is the same as 0.25 hours because it's 15 divided by 60. So what's her average speed in miles per hour for the total round trip? Well, rate or speed is just distance divided by time. So what's the total distance of the trip? Well, it's still 60 miles. That part hasn't changed. What's the total time for the trip? Now it's 1.5 hours. Miles per hour. So you can just take 60, divide it by 1.5, and that is going to come out to just 40. Okay, so miles per hour. So the average speed with the construction delays is just 40 miles per hour. Correct answer for this one is letter H. Just want to point out also, you could technically do this one via back solving as well, starting with the answer choices and plugging them in. And so what I mean by that is say you started just with F, okay? So if her average speed was 30, miles per hour, and the total distance is 60 miles, how long does that take? Okay, time equals distance divided by rate. So take 60 and divide it by 30. Okay, take 60 miles divided by 30 miles per hour. That comes out to 2 hours. Does that match the information in the problem? No, because it says it's normally 1 hour, but it's been taking 15 minutes longer each way. So 1 hour plus 15 is not 2 hours. So that tells you that 30 is wrong. Now, in theory, if you're going to use this approach, you would start in the middle with answer choice H, and that one would work. So then you wouldn't have to check any others. You wouldn't start at the end. You'd want to start in the middle and see if it was too high or too low, because if it's wrong, you could eliminate H and either the two above or the two below. But just to point out, you could solve this one using back solving as well. All right, let's talk about the one a couple below it now, 56. So this person is walking between 2 points on an XY coordinate plane, and either only going, basically either these types of directions, nothing diagonal, just going like horizontal or vertical, or in this case they say parallel, perpendicular to the x-axis. And they give you this expression here, and they want to know, which is basically the distance between the 2 points, say whatever, start and end. And they want to know which could be the following pairs of points. So what we're looking for here is, in this first absolute value expression, okay, where we're subtracting these two values, these have to both be of the same coordinate. So they either must both be x's or they must both be y coordinates. So you're looking for an answer choice that has 6 and 1 in basically the same position in the points, meaning 6 and 1 have to both be first or 6 and 1 have to both be last, because they're being subtracted, and when you're subtracting the distance between two horizontal or two completely horizontal points or vertical points, the other coordinate is the same value. So you really are only subtracting the one that changes. In other words, from here to here, I'm subtracting the x coordinates to get the distance because the y coordinates are the same. So if I subtract them, they're just 0. They don't matter. Same thing from here to here, if you're calculating the distance. So notice when you go through the answer choices here, F is the only one that has 6 and 1 in the same kind of corresponding positions because both y values. Similarly with 2 and -5, the only there are F also has them in the same thing, so that checks. Now if you look at it, H also has 2 and -5 in corresponding positions here for the y's, but in the x's, it has 6 and -1, which would give us 6 minus -1 in the parentheses, but that's not what we have. We have 6 minus +1. So the correct answer for this problem is letter F. And again, all you have to do is match up the two values inside the absolute value signs into the same corresponding positions, either both x's or both y's in the coordinate points of the answers. All right, let's talk about the very last problem on this test, number 60. Here you have a graph of a function, and basically wants to know which of these matches it. Now, of course, you could go through and you could graph all these out on your calculator and see which one matches this exactly. But just in the interest of saving time, I'm going to go through kind of the theory behind it and how you could figure out without doing that, or at least narrow it down to maybe 2 or 3 choices, and then you would only have to graph, 2 of them instead of, say, graphing all 5 and trying to see which one matches it exactly. So a couple things to note here. First of all, there is a hole in the graph at -2. Okay, that means that there's going to be a factor that appears in both the numerator and the denominator, and it's going to have the same power in order to cancel out. Okay. Also, because the hole is at -2, that means the factor associated with is x plus 2. Because if you set x plus 2 equal to 0 and solve it, that's how you get x equals -2. Okay, so we're looking for this factor in both the numerator and denominator, and more importantly, it has to be the same degree. Okay, if it was a different degree, then one would cancel out, but there wouldn't end up being a hole there. There would still end up being either nothing or an asymptote. So first of all, this doesn't even have an x plus 2, so we can get rid of that. This doesn't have an x plus 2, so we can get rid of that. This has x plus 2 top and bottom, same degree. F has it top and bottom, same degree. This one has x plus 2 top and bottom, but the degrees are not the same. Therefore, we can eliminate this one as well. So we're now down to 2 choices. So at this point, it wouldn't be that much work to just go to the graphing calculator and type each of them in and then see which one matches. However, you can actually determine which one of these is correct without needing to do that. And here is the reason. Here's how you can do that. Notice on this graph, all the y values are positive. Okay, everything is above the x-axis. Okay, they're all greater than 0. Therefore, the correct answer has to be letter J. Because, first of all, these cancel out, right? So really you're looking at a 1 over x versus a 1 over x squared. Well, here, when in the top one, when x is negative, you would expect to get negative values, okay? Because if you plug in a negative value here, it's going to be 1 divided by a negative value. However, in J, plug in a negative value, gets squared and becomes positive. So all the values are going to be positive for J, okay? Therefore, that's how we know it looks like this instead of, F, which is going to look different because it's going to have, but it's because it's going to have negative y values or, points with y coordinates that are negative. In other words, there's going to be some part of the graph that's below the x-axis, but that is not what we have. Therefore, it has to be J because all of the y values are above the x-axis. And I mean, you could also just take, you could just, again, take, say, -1 and plug it into each of these and check. So, for example, for F, right? -1 plus 2 on top is 1. -1 plus 2 on bottom is 1. So we get 1 over -1. Therefore, for F, when x is -1, y is also -1. Do we see -1, -1 in the graph, which would be down here? No, we don't see that. As compared to J, where it becomes 1 over, -1 squared, which is just 1 over 1, which is 1. So in other words, in J, the point on the graph is -1 comma 1. Well, yeah, that's right here. That's on the graph. That just confirms that J is the correct answer. If you enjoyed this video, if you have any questions or comments on these problems, please do leave them below. Otherwise, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. And of course, as I mentioned earlier, check out my Improve Your ACT Math Score course if you're looking for more resources to help raise that ACT math score of yours.